Yeah, so last few classes, we know IP addresses, we know MAC address, we know ARP, we know basic networking. That's what our current understanding is. Uh, so today we will do something called MAC table, or MAC address table, let's say. Today we'll see that MAC address table, let's say, sentences. The few points. First is MAC address table is used, MAC table used at switches, which means normal computers don't store MAC table, only switches store MAC table. So the reason is same only. For example, so I told you last time, switch has many ports. For example, if I double click the switch, the physically it has many ports. Each port you can connect a computer. You can connect a computer here, and so on. You can connect all the computers here. So which means each port belongs to one computer. So let's give some names. Port 1 maybe, port 2, port 3, port 4, example. So port 1 is connected to maybe computer 1. Port 2 is connected to computer 2. Port 3 is computer 3, 4, 5, and so on. So you can see it. For example, let's say I double click. I go to config. Not see it here. Let me see. Okay. Let me see config here. Okay, this is my MAC address. You typically see it here. Maybe settings, I just stop it. I just have to go to settings maybe. Settings. So you will get like, for example, this computer is connected to port 1 of switch. So the numbers will be visible here. Maybe some settings I must have stopped it. So I'll just ask ChatGPT to get the numbers. That's right. Cisco packet tracer. Show port numbers enable setting. Okay, go to top menu, click options, select preferences window, always show options. Okay, go to options. Sorry, preferences. So always show port labels. Maybe let's see. You see. Okay. Okay. Do we need anything else? Play sound? No, not required. I think that's it. Yeah. Now you see by zoom it, we can see this. For example, this switch has 4 ports: port 1, port 2, port 3, and port 4. So each computer is connected to each port. For example, this computer via port 0, when this computer has port 0, is connected to switch port 1. So this computer port 0 is connected to 2. This is connected to 3. This is connected to 4. You can ignore these. These are very just same only for all because one computer, one port. But switch has multiple ports, you can see. So that's why you have 1, 2, 3, 4. Let's try one more computer. Let's add it. Click one more. Let's say this time I'll connect laptop. So zoom out. So now I'll give some connection wiring here to here. Okay, now you see it's connected to 5. So this computer doesn't have my IP address set, so we'll have to give it. Let's give IP address of 168.1.10 maybe. Good. So you can see it's connected to 5. So you can add as many as you want based on the number of ports. So this switch have, let's count how many ports we have. 1, 2, 3, 4, 5, 6, 12, 24 ports. So this has 24 ports. So you can connect 24 computers. So these two will leave it. These two will leave it for something else. But yeah, these 12, these 12. So total 24 computers can be connected to this switch. Maybe we have different types of switches also. Let's see this switch. Let's see this switch. This switch is different. It doesn't have anything, nothing, but you can, okay, you have to power it on. Yeah, so it depends on the switches. Like maybe let's try this switch, PT switch. This PT switch has these things, but you have spaces. You can add some other things. Yeah, it depends on the switches. PT bridge, let's see. This is different. Yeah, it depends on the switch, but by default, we use the current one, so we can connect. Yeah, for this switch, we can connect 24. That's the max. All right, so let's remove the computer. Or maybe I can keep the computer. It's okay. Or I do big, maybe. Let's make it big. Second. Okay, I have to change these also here. Anyway, it's okay. That's fine. Okay. You can see switch has 1, 2, 3, 4, 5 ports. Each port is connected to one computer. That's all. So now this is a physical connection. Physical means you are physically connecting switch to computer, right? But switch has a small software inside or small memory inside. Uh, that memory stores the which port is connected to which computer. So that's where the MAC table comes. So MAC table stores the data of which port is connected to which computer. It's like a small table, something like this. Port number, MAC address, like a device MAC address. Example in our case, let's see, FA01 is connected to this computer. You can store that. FA01 example is connected to, let's give a name. We don't know this computer MAC address, but let me find out. Copy. Copy. Let's give it a computer name for our reference. Let's call C1 for our reference. It's not technically stored, but these two are only stored. But for our reference, this is C1, which is this. I can even change the name. Let me change the name maybe. C1. C1. Let's see C2. This is C2. No, this is, let's make it C4. C2, C3, C4, and maybe laptop. That's it. Yeah, so the MAC table is that only. MAC table is like a table. It stores this data. Hey, which port is connected to which MAC address or which device MAC address. You can see port 01, example one first port is connected to this MAC address. Similarly, there is a second port Second port is, I think this one. This one. This is connected to this computer. Let's say this MAC address. So copy, paste. Something like this, and so on. Maybe max 24. Yeah, this is what MAC table is. It's just like similar to ARP table. ARP table, we have IP address and MAC address mapping, but MAC table is port number, which device is connected to that port is matched. This is just our name per reference. You can see the MAC table at switch only. So let's say inspect, click here. You see something called MAC table. You will not find MAC table for computer because computer only have one port typically. You cannot find MAC table, but you can find MAC table for switches. You can click on seed. You can see currently nothing, but you can see MAC address and port number. VLAN will see later. That's a different thing. It's not much required right now. You can see MAC address and port. Right now it's empty because the switch just started. But as you store the data, as you pass the data, let's go for simulation. Let's say I want to pass the data from this computer to, let's say, this computer. First, I'll data copy. This computer, this computer. You have R ports enabled, so I'll just disable R. So message go to switch. Switch will go here. I would like to pause here. Pause. Now, if you look at the MAC table now, you can see the exact same one. 01 is connected to 9030. 01 is connected to 903. Similarly, 02 is connected to 10E0. 02 is connected to 10E0. So that is the table we call MAC table. Like. So as data passes from one computer to another, switch will learn it. Switch will know it. Hey, the data is coming from this computer. Because when you send the data from this computer to any other computer, you include your MAC address also. You tell that like, hey, this is my MAC address, and I want to send a message to this guy. So switch will know that, hey, this is the MAC address, and this is coming from port 1. So switch will store that inside the memory, saying that, hey, this computer is present at port 1. Similarly, let's say this computer sends the data to switch. Switch will learn it. Switch will be like, okay, I have data coming from computer 2 via port 3. So switch will store that information. So right now we don't have, let's say, computer 2 information here. You can only see these two computers, this and this. But the minute you start sending data, say you send data from here to, let's say, here, when you play, yeah, previous message going back. Yeah, that's previous message. Now new message comes. I pause it and I see the MAC table. Sorry. You can see. You can see all computers data is available. So that's it. That's the final. But switch still doesn't know this MAC address. I'm sorry, this laptop port because nobody has sent data to this laptop. So switch does not know the port number. That switch does not have this table, like I mean that entry of this laptop because nobody is nobody sent the data. But the minute you send the data, switch also will know it. Like, let's send and the message from here to, let's say, here. Okay, that's the previous message. Done. Now new message comes from here to here. Now I'll pause. I'll go and check the MAC table. Now you see all ports, 5 ports are there. Each port has one device MAC address. The table is finally filled. That's it. Once the table is filled, then you don't need to store anything because already data, everything is there. So next time any other data is coming, yeah, it will go automatically like to the right port. So this is how MAC table is stored. MAC table is created inside the switch memory. Like, yeah, I would like to pause and see any questions, anything up to this point. Is it clear or is it complex? All three messages done. Yeah. Could you let me know if it's clear or still confusing or something? Maybe I can summarize or reduce it. It's confusing. At the end of it, it's all about table storing the data. That's it. This table. That's what the MAC table is like. Yep. Any question, anything, just let me know. Uh, so maybe we can learn about small attacks here. I mean, not attacks, but vulnerabilities, let's say. If let's say I have one more computer, it's a laptop. Let's this give sorry. Let's say this is an attacker. So attacker. Let's say attacker is connected to the switch somehow. Let's say. Okay. You can see port 6. I'll just give some IP address. Oh. Let's say this is the attacker. Just mark it red. Let's see. This one. Yeah. Let's say this guy is an attacker, is connected to switch. Now what he can do is he can do few attacks. So I'll just quickly name it. Attacks on MAC table. Let's say what he can do is first is uh, uh, we call something called MAC spoofing. So Max, okay, Max spoofing. I think it's we already discussed about this one. Let me just check. You can do something like this. For example, let's say you can pretend like he's not he's this computer. you can replace the entries or you can change these entries. Like let's say that's an attack. Example, let's say port 2 connected to this IP. I'm sorry, this MAC address. Now what he can do is he can, let's say, change this entry, something like his own MAC address. Maybe let's say this. So you can say that like he's actually his original account is connected to, let's say, his original MAC address is connected to port 6, I think. Ah, let's see, so, port 6 is connected to originally, this is original, real, but somehow he manipulated the table in a way like he's connected to 2. Now what happens is, let's say this entry doesn't exist, this entry only exists. Let's say this also doesn't exist because 2 is replaced by this one. That means this entry also does not exist in a way. So the new table would be looking like this. So something like, yeah, new table will be looking like this. You just changed it, like port number. You just swap the is MAC address, not this one. So now what happens is, let's say now computer 1 wants to send a message to, let's say computer 3. So the message will go to port 2. I mean, the first message will go to port 1, which is this port. So the message will have to navigate to port 2, but he knows that port 2 is not connected to the real computer. It's connected to this computer. So in a way, the data was supposed to go to the original computer, I mean, the real computer goes to the attacker. So in a way, data is going to the attacker instead of this guy. So in a way, he's like taking the things. So that's one attack. I think clearly there is a documentation. Maybe so something like this only. This is a MAC table. This is what we see: MAC address, port number. There are two other things also: static, dynamic, and VLAN. VLAN we will see later. These are different concepts, but we'll see later. But focus on this and this. So let's see attack. Attacks is okay. This flooding attack. Flooding we're talking. Spoofing attacks. This one. Yeah, it's like this. You can see. So it's like switch PC to MAC address is this. Attacker changes their MAC address to okay. Okay, what he's doing is he's changing his MAC address to this original address actually, but he's connected to this one. Like interesting another device changing its MAC address to match the legitimate one. Switch updates MAC table, thinking the attacker is the real device, which receives it up and current. But here it's not clearly mentioned it actually. Let's use ChatGPT to MAC table uh, attacker changing changing values, stealing data. In 12, no, 7, values. Let's see. Okay. So PC1 is the victim, PC3 is the server, PC2 is the attacker. They each have their MAC address, each have their MAC address, each have their ports. The attacker spoof MAC address to steal the MAC table falsely. All three are different. Okay. Now step by step two. PC1 attacker server. Okay. Let's say from PC1 to server via F3 correct path. Okay. PC1 to server. Okay. That's true. But instead, attacker launches max spoofing. Attacker sends fake Ethernet frames pretending to be from CCC server. Those packets are not repeatedly from F2 and switch address. You can see the server is CCCC, the attacker is BBBB, but here it's reverse. Here it's changed. Uh, Here it's like this is the attacker BBBB. That's what attacker is BBBB, but it's changed to CCCC, attacking spoofing server. It's connected to port 2. Now PC sends data to the server. It goes to the attacker instead because the attacker is CCCCCC, like something like this. But actual CCCC is this server. So I mean, this is table chain. Sorry, MAC address swapping. You swap the MAC address from real device to attacker device. That's one. What about port? Let's see port. What about port swapping? Port is something like this. So FA1 allows only this. F2 allows this one. MAC table entries, switching by spoofing different address and different ports. Let's see this one. Player one victim. Player one server is CCCC. FA3. Attacker is BBBB. FA2. This is normal MAC table 1, 2, 3, ABC. Now attacker switches. It should be. You can see it's port changing. ABC is common. ABC is common. But port 1, port 2, port 3, it is changing to port 2. It is changing to port 2. So anyway, is switching the entries. Actually, port 2 is not AAA. It's supposed to port 1 AA, but it's changing it to port 2. Similarly, this also same. Finally, attacker drive traffic meant for other device. That's all same. I mean, two ways. One way is you can change the port to the address. The another one is you can change the MAC address to change the data path. Like two ways actually. Both are legitimate. I mean, not legitimate, but both are possible attacks. Again, attacks we'll see on ethical hacking module, but just want to tell you that there is a possibility to attack MAC table also. That's all the main point. How they do it, we'll see in the ethical hacking module. But right now, you just understood they can be attacks possible. That's all. That's all need to know at this time. It's all same only. Flooding attack is another attack. You